Hello, Applied Math 40S. It's Mr. Morrow here. Unfortunately, it looks like my daughter's sick. It's Sunday evening, and so I'm recording this lesson for you for Monday. I've got my graphing calculator handy, it's very exciting, and we're going to do section 1.5 on investments involving regular payments. So here we go. Okay, so to start off, we're going to be looking at saving for retirement, and we're going to use a couple numbers here that are accurate kind of numbers. So first thing here is that in 2001, RBC did a survey of Canadians, and most Canadians are aiming for about $778,000 in savings by the time they retire. Now, how do we measure how much money you can make when you invest? Well, we're going to use what's called the Dow Jones Industrial Average. You may have heard of the Dow before. These are a bunch of safe investments like IBM, 3M, McDonald's, Microsoft, Disney, Coca-Cola. You know, the companies that you know that have been around for a real long time and are pretty safe. And if you invested just in the Dow, you would earn about 8% compounded annually. Now, this is not exact. It ignores something called dividends. We'll talk about that a little later, but let's just use this 8% as our number today. So here's the first question for you. If you wanted to retire at 60, that's 43 years from now for you, how much would you need to set aside today at 8% compounded annually to save $778,000 by the time you retire? So you're going to save for 43 years at 8%. How much money do you have to set aside right now in order to have enough money at that time? Okay. Why don't you try figuring this out either using a formula or trying to do it with your finance calculator. Hit pause and start up the video again in about 2 minutes. Okay, welcome back from pausing. Okay, so this is the formula that we've been using the entire time, and I'll use that now. The amount I have at the end is actually $778,000. The amount of interest per period is 8% every year, so that's just 8%. And the amount of compound periods, well, it's once per year for 43 years, so n is going to be 43. Okay, so we plug our formula in. We get 778,000. Oops, missed a zero over here. Hope you didn't notice. Equals P, which we don't know, times 1 plus 0.08, all to the power of 43. Okay, I'll divide both sides by this chunk over here. Okay, so I'll divide both sides by that. The result is that I have 778,000. I should have chosen a nice round number, divided by 1 plus 0.08 to the power of 43 equals P. And type that into your calculator successfully, and you'll end up with P, our principal, being $28,428, and don't forget the pennies, 77 cents. So if you put that money aside today, hey, at 60 years old, you'll have that $778,000, and boom, you can retire. Isn't that wonderful? So why is this example ridiculous? It's a stupid example. Well, there's one thing that really makes this example kind of dumb, and that is that who here in this room is sitting on $28,000? Okay, you just don't have $28,428.77 in your pocket. So does that mean you can't retire and you might as well just kind of give up now? Well, that doesn't make sense, right? You've got 40-some years to go. You probably can figure out a way to retire, right? And so what are you going to do in order to do that? You're going to make what we call regular payments, okay? And if you make regular payments, you don't have to pay everything into your retirement savings when you're 18 or 17. You can pay a little bit, say every month, month after month after month, for years and years and years. So here, let's really look at the same example here. You want to retire at 60, that's 43 years from now. How much do you need to set aside at the end of every month if you're going to earn 8% compounded monthly, and you want to have eventually $778,000 in your retirement savings? Okay, now we're going to use the finance calculator in this case, so please take that out now. I'd like you to take a moment to try to fill in some of the blanks and see how much of it you can fill in. By the way, the thing we're looking for, and so the thing you shouldn't fill in, is the payment. That's what we don't know. So I'd like you to try to fill in all the blanks, so pause now. All right, welcome back from pausing. All right, well, some easy things here. We know that our interest is 8% per year. We know actually that we're starting with $0, and by the end we need $778,000. Now, how many payments are we making? We're making a payment every month, so there's 12 payments per year, and we're compounding every month, so there's 12 compounds per year. Okay, and then this payment thingy, always have it set to end. Okay, now what about n? N would be the number of payments. Well, this is going to be 43 years times 12 payments per year. So if you type in 43 times 12, you'll end up with a number. Let's see, I typed it in and I got 516. Okay, and now we go to hover over PMT and you type alpha solve. So do that now. Okay, I just typed it all in into my calculator and I get negative $173, and I guess I could round that 856 to 86 cents. Okay, so I'm going to have to make a payment of $173.86 every single month starting today in order to 43 years from now have $778,000. So now $173.86 every month. That's something that's much more reasonable to be able to set aside. Now, in order to answer that prior question, we need to take a moment to recognize how much work is involved if we use our regular compound interest formula. Our regular formula just looks at a single amount of cash and says, how much does that single amount grow by? Okay, so for example, if we save $500 every month for 10 years at 6%, well, we'd have to ask, how much is that first $500? And we do 500 times 1 plus 0.06 divided by 12, because it's compounded monthly, for 10 years is 120, and you calculate that out and get some amount after 10 years. That's the first payment. Then you do that again for the second payment, so you do 500 times 1 plus 0.06 over 12, but this time the second one, oh, we're only going to have that in there for 119 years. Okay? And if you type that in and type the next one and type the next one, and 120 payments later, you type it all out, and then add them all together, and you haven't made a mistake, guess what? You'll find out how much money you've saved after 10 years. So the amount of work that we have to do using the formula that we've used so far is an insane amount. It would just not be feasible to answer this question or the last question using the formula that we have. So we're going to rely right now in this course on the financial calculator that we have. So we'll use the TVM solver in order to answer these kind of regular payment questions. In future courses, if you do kind of a business school kind of thing, you may see that actual formula for regular payments, but we won't talk about it in this course. Okay, I'd like you to take a moment to pause and read example 3 on page 51. So example 3 on page 51. And then after having read that, I'd like you to not read the solution, but just take a moment right now to flip to that. Okay, just to clarify, this example says Jeremiah deposits $750 into an investment account at the end of every 3 months. Interest is compounded quarterly, the term is 3 years, and the future value is $10,059.07. And we're asking, what annual rate of interest is Jeremiah earning here? Okay. Well, let's fill in our TVM solver. So first up, we start with $0, and then we put $750 of payment in. By the way, should that be a positive 750 or a negative? Well, we're going to treat it as a negative 750. Okay, so you want to have a negative sign in front, not the minus sign, but the negative sign. Your calculator should have 2 different buttons that are negatives. The one that's all the way at the bottom, just next to the enter button, that's negative as opposed to minus. Okay, so let's enter the rest. The future value is eventually positive 10,059 and 7 cents. Don't lose that 7 cents. And let's see, what else do we have? Oh, it's every quarter for 3 years. So that's 4 times a year for 3 years. 4 times 3, that's 12 payments. How many payments are we doing per year? It's 4 per year and 4 compounds per year. And again, just always highlight the end unless it says otherwise. Okay, that means now we get to hover over I and hit alpha solve. Okay, I just typed it all in and I hit alpha solve and I get 8.00000191, so we'll just call that 8%. Okay, for our next example, I'd like you to read example 4 on page 52, so flip to that and read that example, but don't read the solution right now. I'll take it up in one moment, so pause now. Okay, so page 52, again the example here, just to reread it for you, is Celia wants to have $300,000 in 20 years so that she can retire. Celia has found a trust account that can earn a fixed rate of 10.8% compounded annually. And question A, what regular payments must Celia make at the end of each year to meet her goal of $300,000? Okay, well let's fill this in. It's going to be 20 years and she's going to make one payment every year, right? So it's going to be 20 payments. She's making one payment a year and it's compounding annually once a year. Her interest is 10.8%. She's starting off with no money, but every year she's going to add some unknown payment. I'll circle that because we don't know what that is. And eventually, at the end of it all, she will have $300,000 saved. Okay, oh yes, and always that payment is on the end unless it says otherwise. Okay, so we enter it all in, and then you can alpha solve for that payment. So why don't you do that right now? Okay, so I typed all that into my calculator, and then I hit alpha solve just now, and I get negative $4,781 and 0.089, so that's 0.09 cents. So that's how much money Celia will have to plop into this account every year so as to have $300,000 at the end of it all after 20 years. Now there's a part B to this, and it's saying how much interest will she earn over this 20 years? Well, here's how we'll approach that part B. So for part B, in an ugly yellow, so I'm going to switch colors because you can't probably read that, we're actually making $4,781.09 of payment every time, times 20 payments. So the amount of money she actually put in was $4,781.09 times 20. Typing it in now, I get $95,621.80. So this is not the answer, but this is how much money she put in. How much money does she have at the end of it all? Well, she has $300,000 at the end of it all, so the amount at the end is $300,000. And the amount she put in is $95,621.80. So the interest, we could say, is the difference here between these two. And if you take 300,000 minus the 95 and change, you get 204,378. And just before I get you to do homework, just a final thought here. All the examples you did today, or the homework you're about to do, make one wild assumption, that the payments per year and compounds per year are the same, like monthly payments and monthly compounds. Obviously, it's possible to earn interest every month, but save money every week. So we're going to need to consider this kind of problem another time. So here's some tasks for you to do right away. Hopefully you can get a lot of this done before we start. Suggest you work either individually or in groups, whatever suits you. Try and ask some questions of other people, and yeah, good luck with everything. See you tomorrow.